The FTTx Rapid Network Planner has been developed to increase efficiency and accuracy of designs created for the deployment of FTTx networks. We do this by automating the creation of physical inventory such as pits, ducts, cables, joints, splitters, terminations, with associated connectivity and containment, as well as the design outputs such as construction plans, splice reports, schematics and bill of materials. The planner is powered by ConnectMaster, our GIS-enabled inventory management system, which means it utilises the engine renowned for its ability to record and manage physical network inventory, connectivity and transmission logic for network operations and network design, giving the user an intuitive interface for configuring and dimensioning components and rules for deployment. So let's take a look at the planner. Business rules for network generation are configured into the rule system, which includes options such as the number of fibres to a building, the number of fibres per customer, setting ownership and usage details for shared infrastructure, project components lists, as well as specifying which types of components will be used for the project. Multiple rules can be combined into a single rule set, as they may vary from project to project or even from street to street. Once the rule sets are defined, we can begin planning the network. Let's take a look at a short example of how to use the planner. In this case, we'll connect 10 sites via a planned trench path we have drawn in. A project is assigned here so that all objects generated by this workflow are allocated to this project. In this example, we are deploying a blown fibre network. We select a start point, being the distribution point for the sites that we are about to connect. Now we add the distribution path and destination sites into the planner. The distribution path is chosen. We choose customer sites to be connected. We then tell the planner to find appropriate materials for our selected locations and then execute. The network is deployed, creating a drop segment for each building, designing a trench, microduct distribution, and blown cable to each customer. As you can see in the drop segment, the objects are created from their defined dimensions. Among them, a trench, a microduct, and a cable. In the distribution segment, an additional duct is shown, containing multiple pre-installed microducts. All of these components were deployed based on the business rules and physical attributes we defined earlier, reducing errors and improving accuracy. When the design parameters are outside of the rule set, the planner's conflict resolution highlights the issue and provides options to resolve the conflict, either manually or automatically. We have a feeder planning mode that allows the user to quickly generate ducts and cables from the POP to the distribution hubs, ensuring sufficient fibres are fed for the distribution. Fine control over the planning is also possible, and the proposed objects can be easily manipulated to meet requirements. Smart Edit, for example, has the capability to move a location and automatically update all associated ducts and cables, including their lengths. This also applies to repositioning the route of a trench. With each move, the planner recalculates the length of the installed subducts and cables to produce accurate materials lists and project costs at any stage of the design. The BEP reset is another editing tool that can reset the drop segment to a customer location. This is especially useful if a new distribution path or branching location needs to be used. The split tool is useful for dropping an additional pit over an existing network, with options to split only the trench or also split existing ducts and subducts within the trench. ConnectMaster's GIS supports web tile services like Bing Maps to display satellite imagery to view obstructions or trenching routes not visible from schematic mapping files. Documentation can be easily generated at any stage of the project, including material lists and costing. Construction plans, splice reports, duct connectivity reports, plus a variety of additional standard and configurable reports are available. So, what are the key benefits of the planner? It supports point-to-point, microduct and pond models, It makes planning faster, easier, and more accurate. It gives massive time savings in network planning, editing, and especially the generation of outputs. It increases the accuracy of designs via preset material list and business rules. And as ConnectMaster is a design and operational tool, data can be immediately used by operation teams after construction. If you have any questions or would like a demonstration of the planner or any other features of ConnectMaster, please contact us.